All right, are we ready to get started? Thanks for coming to this presentation. This is a topic that I love, and I'm so glad that it has a space within the summit. The topics that I'm going to be covering, I also have available on my website. In case you don't know, I'dRatherBeWriting.com. First of all, you can get the slides and links from the app. I also have them in this first post. But the bulk of the material that I have about API docs is in this documenting API site from a link on my top nav. Comprehensive course, lots of content, videos, recordings, all this stuff. So if I gloss over something and you want to dive deeper later, this is a great resource for that. The URL is, you just go to I'dRatherBeWriting.com, click documenting APIs. It's actually /learn-API-doc, but there you go. And in that workshop, which I gave here, I actually have a lot of different sections that I cover. I go over like how to use an API like a developer, endpoints, Swagger, and OpenAPI, and so forth. So for this presentation, I've decided to pick highlights from across all these other sections in the workshop and try to compress it into a crash course kind of version, but it's not as if I'm going to race through a million slides or anything. Just taking what I think are the most important aspects of API documentation. Before I get started, help me understand you a little bit more. How many of you currently are kind of documenting either APIs or are in like a developer documentation space environment? Yeah, all right, so about half of you. Okay, this helps me level set and know what assumptions I might have. Also, I like to be informal. If you have a question, don't wait till the end, just raise your hand and we'll address it. Ask anything. Maybe we'll cover it later, maybe we won't. You can always track me down in the hallways and so forth, and we can chat more. All right, oh, I'm also recording this, which I may be allowed to post or not, I'm not sure. We'll see. Now, let's jump into this. What is an API, right? API stands for Application Programming Interface. And the best way to think of an API is through this analogy of a cog, where you have a system on the left, whoa, wrong button. A system on the left, a system on the right, and that link, that interface that connects the two is the API. It allows computers to talk to each other, or systems. It's not as if it's meant for one user to be interacting with another user by manually firing off calls to it. It brings systems together, and the most common and probably frequent example is a flight booking site. I'm sure a lot of you looked on some kind of flight portal, right? Go to Orbitz, for example, and when you do a search, it's going out and using API calls to gather information from lots of different sites, and then it pulls it all back into that portal. Imagine a system without APIs to gather that information. How possibly could that work? You'd have to have a giant database with all this information. The essence of APIs are requests and responses. If you were to narrow it down to just 3 words, that's all it is. It's what can I request and what comes back. Now REST APIs are different from native library APIs such as a Java API or a C++ API because it doesn't really matter what language you're in. Your application could be in Ruby, it could be in Python, it could be in Java, it could be a JavaScript application. It doesn't matter. All of the programming languages pretty much can execute a request to a REST API because REST uses HTTP as what's called the transport protocol. The request is sent out over HTTP. You know, if you think about it, the web works in the same way. I come here to a website, or I open my browser, and when I start typing, for example, https://I'dRatherBeWriting.com, I'm actually making a GET request for a resource that's sitting on that server, and goes out and it contacts the server and it says, I have this information. It sends it back to the browser, and the browser just renders it in a visual way. But basically, REST APIs are also called web APIs because they use the web as the same transport protocol. They send the request. You send the request across HTTP. The server usually has some kind of response in JSON or XML. For example, let's say this is a homes API. You're trying to get like a list of homes. It might have home 1, 2, 3, and so forth. It sends it back over HTTP. Again, HTTP is not tied to any particular programming language, so it's kind of this neutral format. And the application then gets the information and can make use of it. In the case of that Orbitz site, right? It gets the information about Delta and Southwest and other airlines, all that information, and then probably JavaScript or some other framework is going to display it on the site for you. That's really ultimately what APIs are about, at least in terms of REST APIs. Now, there are a lot of other types of APIs that I usually don't focus on in this sort of presentation because they require more programming background. But if you start poking around on GitHub or other places looking for APIs, maybe you want to join an API project to document, you'll find that a lot of APIs aren't REST APIs. They are very specifically tied to a programming language. But because REST is sort of language agnostic, it tends to be a lot more accessible and in the wheelhouse of technical writers and others who don't have an engineering background. And among the types of REST APIs, REST is really growing in a phenomenal way. This is a chart on ProgrammableWeb.com, which is a site that tracks all kinds of web APIs, and it describes them, gives links to them. And in January 2018, they have more than almost 20,000 APIs, web APIs that they've got on their site. This has grown dramatically. I mean, in 2005 and 6, there were less than 2,000, and now it's 10 times that. It's becoming the way to do APIs because if your API is tied to a programming language, you narrow your audience tremendously. I once worked for a company that had a little widget that would do some tracking, and they had a C++ API, a Java API, a PHP API, and every time they wanted to make an update, it was a nightmare. First, they had to find software developers that could code in those languages. Then they had to do testing across 3 APIs, and then once people implemented them, they had to download the code, roll it into their project, push it out. It could take 6 months or more for just a simple update to be pushed out. And given the speed of how many bugs get surfaced and fixes and advances, it just can't really keep up. So the REST model doesn't require you to download a library. You just are accessing a web. It's kind of like, cue the music. I love it. It's just like my website that I demoed there when I went to I'dRatherBeWriting.com, you don't have to manually download information into your own browser and so forth. At any time, you can just pull it, and that's how these software companies can keep up with the pace of development. It's because it's all on the web.
Tom?
Yeah.
Do people do that because they want to be browser specific?
Do people do what because they want to be browser specific?
Like C++ APIs or something that is not a REST API.
Why do people not use REST APIs? Well, REST APIs can be slow. For example, I work primarily with people developing apps for Fire TV, which is a little stick that you put into your computer as one device model. And if every time you wanted to perform some function on that device, it had to go out and make a call and then get something back, it tends to be slow. Same with the video game world. So for a lot of devices, you package the code right into the device so that it's fast and quick and responds well. So yeah, I mean, there's lots of other API growth as well. That's a great question, though. All right, in my course, I kind of walk people through a sample scenario just to give a better sense of APIs. Let's say that you were building an app and you wanted to build some kind of weather check. Let's say you're a cyclist and you want to know what the wind is. You're kind of like wind and temperature and direction because, you know, as you're riding a bike, if you have a super strong headwind, it's no fun. Well, first thing you would do is try to define what kind of information do I need. I need weather information. And you could survey lots of different API sites. You might choose one. This one is from Open Weather Map, for example. And you would look and see what kind of information does this site return. A lot of times when you go to a website, there's a user interface, right? But then there's also an API section for developers. In fact, almost think of any brand. If you just search for that brand plus API, you kind of go into the developer section of that site. I was playing around, I'm like, is there a McDonald's API? You know, does everything have an API? And yeah, it's kind of crazy. You find everything. So if you come into the API section, be in developer land, and you'll see, oh, they've got, you know, lots of different APIs here. Information about the current weather and forecasts, but also relief maps and weather stations and UV indexes and so forth. So this first sense is, you know, what kind of information is available. And you'll find, this is one of the sort of, unique things about the API doc space is that terminology is all over the place. So this whole thing is a weather API, Open Map Weather API, but each one of these individual things is also an API. It kind of has both a singular and a collective usage. But you could come in here and say, oh, I just want the weather, and you would look and see what kind of information comes back. Let's say that in this case, you can search by all kinds of things, by zip code, and they show you a sample response, and you can look and see, yes, this has temperature and so forth. Right, so that's kind of the first step in the developer's mind. And then they'll begin to experiment with it. You know, it's not enough to just read about it. I want to try it for myself. One tool that's commonly used, and there are many similar, but is a tool called Postman. This is a standalone client that lets you make requests right in a little GUI interface. Others that people use might be one called PAW for the Mac, another one called Insomnia people are telling me about. There's some that are built directly into the browser, but Postman is my favorite. So anyway, you can come into a site like this and figure out how do you authenticate. This is the endpoint. In other words, this is how you're going to access the information shown in the response. And you'd have to figure out, how do I get an API key so that I can my request will be authorized. And then in Postman, you come in and paste it. I already have it pasted right here. You can add your parameters. For example, there's query parameters of a zip. You can probably see that. A zip, units, an app ID. And you can click send and immediately see the response down here. This is real-time data that's coming back. Developers like to play around with tools like this so they can get a better sense, especially when they plug in their own data, of the sort of information that your API returns. I've got my Santa Clara zip code there, and so now instead of looking at London's weather or whatever, I get my own. Postman is a super cool tool. You can generate all kinds of things in there. It's not just a way to make requests. You can incorporate open API specs. You can generate things and port them into other systems, generate code snippets, but we won't get into that. Curl is also very commonly used. This is a way to submit the same request, but through the command line. And this is often how, in API docs, you represent the request format. So I'm just going to copy this and open up a terminal. Whoops, clear that. All right. And the way you submit a curl request is first you would install curl. It's built into a Mac and Windows 10 by default, but older Windows would have to install it. And it has this, first the name curl, and you specify the method -x get. So in this case, I'm just getting information, but in other cases, I might be creating things. So there are other methods like post and put. And then I have this resource URL, the endpoint along with some parameters after it that are going to define the location, the units, and other things. And when I hit enter, it goes out and it retrieves it. And now in curl, it's just going to minify the response, so it's hard to see. But a lot of programmers like this because you can do unit tests. You can, it works regardless of the client. It's sort of this, software independent format of showing how to do a request. All right, when you're writing API documentation, there are at least 5 kind of main sections that you'll typically see. These endpoints, by the way, and I always hesitate to fixate on the term endpoint because some people call them objects, some people call them just reference, some people don't call them anything at all. But I like the term endpoint because it kind of encompasses everything that is included here. But endpoint is how you get the resource that's sitting on that server. Thinking back to the Orbit site, there's a bunch of endpoints that are going to retrieve the flight information. And maybe different endpoints retrieve different information. Almost every API doc set has a reference section listing their endpoints, and they will have these 5 sections. It will describe the endpoint or describe the resource that you're retrieving through the endpoint. Literally list the endpoint. Here I'm duplicating the same name, I see, but it's how it often is, right? You have the URL that you use to access that resource as well as the methods available. You list the parameters, and there are several types of parameters. You could have parameters in the header of the request, in the actual URL. In that case, they could be path parameters or query string parameters. And then there's another type of parameter called a request body parameter, and I'll show this kind of in a sample in a minute. You include a request example, like that sample curl statement, and then a sample response. And the response should include an example of a response that probably correlates with the sample request, but also something called a schema or model that would kind of list comprehensively everything that could come back, as well as the data types and any other kind of information about whether it's required or optional and other details. Although I've listed these 5 sections as if you could go to any API doc site and just naturally see them labeled as such, it's not the case at all. The terms vary from site to site, but you will see this general structure. And this structure is really what makes API documentation its own recognizable thing. Anytime you're looking at API docs, you're going to find reference content like this that has this structure. We talk about structured authoring a lot in other contexts, right? Often people associate it with DITA, but in the API doc world, the endpoint structure is really what is apparent, and I'll talk more about that in a minute. Let's show a couple of examples. So in my course, I have a very quick example of a mock endpoint. Let's say that you're being asked to document a surf report endpoint. And come on, where are we going here? In this surf report endpoint, you're going to have different sections. For example, you'll have the endpoint. Wow, I hope this really resolves. Let me see if there's something up here, because I definitely am going to be needing this.
Wi-Fi's windy today.
Okay, there we go. Okay, let's try that one more time. Maybe it just took a minute to render. Okay, so this might be a sample reference topic, right? You've got the resource surf report. It's going to have information about surfing and so forth. You describe it. Then you list the different URLs that you can use to access that resource. Surf report / beach ID, maybe it's a path parameter. You list the method, right? And maybe each of these, maybe there's like a few different endpoints, maybe others that do slightly different things but are still working with that resource. You list parameters, say what kind of parameters can you put into this endpoint. You have a path parameter, maybe you have some query string parameters. A query string comes after the question mark in a URL. They're optional, they can be in any order. You provide a sample requests, often in curl format, right? And hopefully a developer can copy and paste that sample request and just have it work. You know, in fancy documentation, they'll populate the user's API key directly into sample code. You have a sample response, say, hey, this is kind of the data you're going to be getting back. And we're going to define it. What are each of these items in that response? Good API docs define each of these. Bad API docs just assume that the user knows what they all mean. You include the type of data that's coming back, whether it's a string, an integer, and so forth. And that's pretty much it. That is the shape of reference information. And depending upon how many endpoints you have, you could have dozens of these, or you could have just a few. But you'll have this need to templatize the structure so that it's consistent and predictable. Yes?
In this context, where would they get the beach ID?
Yes, so where would they get the beach ID? Presumably the documentation would explain where you get that. In the sample, I don't think I list that. Actually, in the course, I tweak this and put a bunch of errors in there, and that's one of them, not describing like where you would get a certain code. All right, now, that's a mock example, right? And now let's go to a real example. I don't work for SendGrid or Twilio, but I think their docs are pretty exemplary, and this one is one that I wanted to use as a demo. So in this real example, this is at sendgrid.com/docs. And SendGrid is an API that allows you to send email, large amounts of it, in different campaigns and other things. This endpoint here is the mail/send endpoint. And you can see on the left, the method is called post. So in this case, we are creating information, not just getting information. And most post methods are going to require me to configure things, so there'll be a request body parameter. But you can see how they describe the endpoint. There's some information about that's unique to this one. It's not really worth calling out here. Then they have information about how you authenticate, because this is this will require a header parameter, right? Let me see if I can scale this up a little bit. All right. Then they tell you what parameters are required in the request body. And they've got two tabs here, right? A schema, which describes all possible parameters, and the data types, and a description, and whether they're required or not. And then an example where you can flip to it. So this ability to toggle between an example and the definition or the model or schema is very, very common. All right, so in this case, because I'm sending an email, it wants to know, who are you sending it to, who are you sending it from, what should it contain. That's what all these definitions are. There's 68 more properties. They've done a nice job in kind of expanding the view, so I'm not overwhelmed, but there's a lot of stuff that you can configure. And then at the bottom, they list responses. What kind of things are going to come back? Well, in a successful response, apparently you don't get anything. An example of nothing is that, which is empty curly braces. But you could get 400, and in that case, there would be an error, and they describe what you'd see and other status codes. Maybe you're successfully executing the call, but you're not authorized. Anyway, this is a great example because it shows the different sections that I was describing in the other part. Now, there's a key component of API docs that makes them unique from all other documentation, and it's this try it out feature. Not all API docs have this, but a lot of them do, because engineers really like to push buttons and try things out. For one, it helps us learn things better, right? It helps us, when you can try things out, it sort of combines instructional design and learning with documentation in the same package. So, how hard is it to try this out? Well, right within the documentation, I should be able to make a request. You can see that I need to enter my API key. So first I'd have to figure out how I get that. It's not hard to get that. And last night I was like, let me just get the API key. So I have one there, and I'm going to paste it right here. All right, the request body. Now I have to sort of look back at the docs and see what fields are what, and I could go in here and manually customize this, but in the interest of time, I sort of just got something ready and I'm going to copy and paste in there. But I'm defining, who I'm sending the email to and from, and so forth. So I'm just going to paste this right there. That is all that is required for this endpoint. Now I click send request, and I wait for my empty response to come back. Empty response. In a real or in a normal API, you'd think that you'd get a better response, but for whatever reason, that's it. And you can see other information about headers, right? And so, did this work? Well, normally you would get more information returned in the JSON. But in this case, you can also just open up your email. In that case, I had it sending to my email. And there it is, this hello world email. This is sent from that API. You can see I've done it a few times just to test. They also have this nifty little thing down here, code generation. This has taken the information in that try it out field section and automatically packaged it up into other languages, including curl. So if I wanted to submit the same request through curl, clear that, I could come in here and it's copy and pasteable because the API key is already in there. And again, if I were to go back to my email, I would find similar sort of email coming back in. There we go. And so this tried out functionality is the defining characteristic of cool API documentation. You'll find different platforms give you different functionality. In this case, maybe you think, Twilio and SendGrid have all kinds of UX designers and I could never do this. But actually, this is all just on a platform called Stoplight. If you go down here, this is all you just pay a fee or whatever, the SaaS type of software documentation that you can do, and you don't have to do any of it yourself. So now the other cool thing is that all this information, it's not as if if you were to subscribe to Stoplight or buy into their model, and there's lots of others too, Swagger Hub and so forth. You wouldn't have to go in and manually type, here's this mail send endpoint, here's all the different request parameters. No, the API doc world has evolved to structured information. And that structure is called the Open API Specification. Up here on the right, there's a nice handy link. If I go to it, you can see that this is the structure that is powering and populating this entire interface. This entire interface. They may have some custom topics here they've added, but by and large, all of the API information, that we're kind of looking at is pulled from this Open API specification and put in here. Just because, or just as all the data content management systems need structure to kind of parse and process and render and manipulate the information, these other tools like Stoplight and so forth need structure in order to predictably grab the information and populate it in ways that make sense. It removes a tremendous burden if you're using a method like this. Now you don't have to go figure out the site. All you have to do is come in and define your content using this specification, which is easier said than done, but that is the essential task of that. All right, any questions before we kind of move on? Yes?
Does Stoplight integrate with things like WordPress?
Does Stoplight integrate with WordPress?
So if you have a
I don't think
WordPress
so.
site,
Yeah.
what do you want to add?
I don't think so. I mean, it's kind of its own output. Maybe in the future, I don't know. But I'll talk more about the publishing tools here in a minute. Let me jump into some other sort of unique characteristics, and we'll circle back around to the tools thing. So API docs, they're different from other types of documentation because they have this reference structure, right? They have a component of interactivity. Users can try things out. I think that alone is something that is a need that a lot of software doesn't understand. If I go wander the expo hall, am I going to find software that says, yes, if you're documenting an API, our software lets users execute and try out requests? I don't think you will find that here. A Hello World Getting Started tutorial. This is very common. It's not always called Hello World, but jumping back here with the same model, last night when I was trying to figure out how do I plug into SendGrid, I checked out the Getting Started, and there was a how to get started in 5 minutes. This may not be it, but one similar to it. You know, it was very enticing. It said, you know, get started in 5 minutes, and I want to be able to see something from beginning to end and actually work. Pretty impressive to do that. There's another big emphasis with API docs is that the docs have to sell the product. If let's say that you are a business and you want to send a lot of email. It's not like you can download a little application and sort of play around with it and then maybe consult the docs. No, you learn about the product through the documentation. The product and the docs are much more intertwined. And as a result, there's a much greater need to have a very attractive set of documentation because that is selling your product. It is essentially your product's user interface. You know, in a regular user interface, you would push buttons and so forth. In the doc interface, you see curl requests that you just copy and paste to execute similar sort of functionality. But this need to have docs that, you know, don't just instruct and help and clarify, but actually sell the product means you have UX designers building cool looking interfaces that will actually sell it. There's also this split between API reference content and conceptual content. Notice even in SendGrid, they have a little split path here. You want the reference or do you want the more conceptual documentation? And this leads into a really big challenge in API docs is that let's say you've created this specification that describes your API and renders out the reference. It doesn't always integrate with your conceptual docs. So even here, if I click this link, it takes me into the stoplight display, right? But if I click this link, this takes me into the more conceptual display, and they're different sites. They've just tried to brand them to look similar, but they're not. This is not powered by Stoplight. This is another characteristic is that the bulk of the conceptual docs tend to be written with Docs as Code tooling. If I scroll down here to the very bottom, you'll see this little edit this page link. See a mistake? Edit this page, you know? And if you click it, you're like, wonder what they're using. You can see that their documentation is on GitHub. They have a section where I could log an issue. Maybe I could say, hey, I noticed that something is wrong in your code or something you've got a typo. I could actually log it. Or let's say I was a person who wanted to actually make a tutorial or something. I could go in and add this to their docs, submit a pull request, and pull request would say, hey, check this out, and if you like it, roll it back into your docs. It's also kind of handy because once you have their doc repo, you get an inside view on their documentation. You can see their whole doc repo, SendGrid documentation, first line. This is a Gatsby site, right? It's kind of cool. That's exactly what I was curious about. I'm like, what did they use? And it's very common that the tooling used for all of these API doc sites are this breed of static site generator. If I go to static staticgen.com, you'll see many. Jekyll, Next, Hugo, Gatsby. You see, this one is trending in part because it's built on React. If you're a UX developer, chances are you might already know React and like it. So why not build the doc site using it, right? You've got the same framework, you're building probably your website to also build the docs because you want to brand them together. Probably the most popular ones for docs are Hugo and Jekyll. Hugo's super fast, you can build massive sites very quickly. Jekyll's been around the longest. It's kind of this reaction against bloated content management systems. We want to simplify things so we don't have databases and PHP requirements and other modules on the server that need to be present. These sites just spit out HTML, static HTML. You upload them. You can upload them in GitHub. You can upload them in any host, really. As a final sort of unique characteristic of API docs, they don't really have many PDF or localization requirements. You know, PDFs, I would be surprised to find any PDF on this SendGrid doc site. And I wouldn't typically find it localized. In part, that's nice because the tooling with the static site generators often doesn't support PDF or localization. So, or search even. If you get into the search here, what are you looking for? Get started. Does anybody know where this search is probably powered from? It's not a Gatsby search. This is coming from Algolia, I bet. Yeah, search by Algolia, which itself is an API that you use to integrate search into your site. If when I type this get started, it's actually making an API request out to an index of my content or of this content on Algolia, and it's returning the content as well. So it's sort of how these sites are put together. All right, I talked a little bit about the opening. Let me just ask, any questions? Yes, in the back.
Why wouldn't there be a need to localize them?
Why wouldn't there be a need to localize the docs? Sometimes there are. I wouldn't say there never are needs, but I don't know. Maybe programmers in other countries are used to just like reading in English. I'm not sure. There are other challenges. People pointed this out in that, like, if you translate, let's say you translate all your API docs. Well, all the endpoints aren't going to be translated. The parameter names aren't going to be translated. All the code names aren't going to be translated. So it's kind of like you translate the conceptual information, but the raw code doesn't get translated. So to some extent, a person still is going to have to kind of understand different words like mail-send, right? That's the endpoint name. If you translated that to Spanish or something, it wouldn't work. But anyway, I don't have any more insight about the localization aspect of it than that. Another question.
You mentioned kind of using the site as selling also
Yeah.
the API as a feature. Do you feel there's a need to kind of then wrap it in more of like some sort of content that's more like an executive summary of like what you can do with this? For instance, I'm with a B2B software company, and a developer isn't going to be thinking, hey, we want to integrate with these guys. Let's go look at their API. It's going to be somebody higher up or somebody in product marketing.
Yeah, so you're asking, is there a need for an executive summary that wouldn't necessarily speak to developers, but to business decision makers? Definitely. I mean, you're absolutely right in that there's different audiences, and too often in API docs, this larger story gets forgotten. I think we sort of often let marketing tell the why, and we tell the how, and I don't think that's a great model. But that why, that larger story, is often forgotten. Even if you look at an overview for any API, chances are it doesn't clearly articulate the story of their product or what problem it's truly solving in a clear way that speaks to people. It's often sort of assumes that you already know what the product's for and you just need reference information. So yeah, there's plenty of room for that.
And that's kind of our problem.
Yeah.
It was marketing was just like, oh, these are magical. Just tell people they're out there. And
Yeah.
you can go to Swagger and figure it out.
A few other points. Now, does this session go to 10:45 or 11? 11, okay. That's what I thought, but I wanted to make sure. This Open API specification, I want to talk a little bit more about that because it's also sort of synonymous with the term Swagger. Initially, Swagger was the name of the specification, but it was sort of tied to a company. Eventually, Swagger became open and wasn't tied to a company, and they changed its name to Open API. Now, most of the time, the word Swagger refers to tooling that supports the Open API specification. But the basic idea is that when you have structured information, it can be machine processed. And one common open source tool is something called Swagger UI. This is a project you download from GitHub. It's free, and it looks kind of like this. They have a demo called Pet Store. Come in here, and you can play around with it and see the output. Swagger Pet Store or Swagger UI collapses all your endpoints into expandable sections, and you can play around with it. And you can even try it out here, right? Remember, trying it out is the central feature of these docs. So if I come in here and type Tom Pet, I can execute the call, and I can see how you would make the call in curl. I could copy and paste that in curl if I wanted, but I actually see the response right here. It's if you were to look at it, you would see that I've created Tom Pet, and I could go and retrieve that and so forth with the other endpoints. But essentially, this whole framework just renders, this Swagger UI framework renders whatever Open API specification file you want to pass it. For example, let's come back to that SendGrid Open API specification file. Where was that? There we go. And just for fun, I actually haven't tried this, but if you come back and figure out where this, where did you go? Oh, back here. Okay. I'm going to pop this in and hit Explore. And now all of a sudden, Swagger UI framework is rendering the SendGrid. This is kind of like the Java doc equivalent, because most developers who have been working with REST APIs will understand sort of the organization and logic of how this is laid out. But you can see that by just describing your content in this structure, you've suddenly freed yourself from any kind of lock-in to a specific visual technology to view it, any kind of software. You might decide, I like Stoplight, or there's another one called README.io. You know, there's one called Apiary. There's a dozen or more. This is fun. We're like cruising through all these things. Now, the reference information gets the most attention in API docs, but there's another aspect, the conceptual part, and that's often where technical writers are pulled in, and where you write even more. I mean, sometimes developers will take the lead on the reference because it's sort of close to them. They know these parameters, they've been coding it, and it's very easy to write. But the conceptual topics include things like, how do I get started? How do I authorize my requests? What kind of status codes come back? How do I know what the limits are of how many times I can make requests? How do I actually use these endpoints to achieve the goal that I'm trying to do? I want a tutorial. And what if I'm trying to implement this on maybe Android or iOS? Do you have an SDK, a software development kit, that's going to implement your language agnostic API into a specific language that I'm using? So I'm just going to talk a little about each of these. The getting started, now most documentation has a getting started section, but in the programmer information world, there's this whole concept of a hello world tutorial. And you want to get a user started from beginning to end in as small amount of time as possible. So that SendGrid tutorial that said get started in 5 minutes, it's like really enticing, because to think that I could actually make a request and see it work, even as small as sending a simple single email in 5 minutes, pretty cool. And the shorter time you can get, the larger adoption. Now that I've already used it, I'm like, this actually works, I can build a whole newsletter campaign and manage my subscribers. You know, it might take weeks, but just get that initial nugget of getting started. Super helpful. Another key topic is, how do I authorize requests? There will always be a need for information about API keys or some other method, and where do you put them in the header, in the query string, how do you get them, that cost any money, that kind of thing. So that information is also often coupled with your getting started. Status and error codes are another common part, right? You want to know, once I submit this request, what's coming back and what number in the message header am I going to see. 200 is usually okay, but you could have a lot of custom status codes. Maybe you've got some special status code around mail subscribers. Maybe you maxed out a limit, and so you'll document all these so that people can see right in as they're coding how to overcome errors. SDKs and sample apps are a huge part of API docs that is often the most difficult. I have a quick example here from PayPal. Here's the PayPal PHP SDK. So if you wanted to incorporate like PayPal buttons on your website, and your website's powered by PHP, they give you all kinds of information, sample code, PHP specific docs about how to do that on your PHP site, and they have this for a number of other languages too. So in order to really dive into the SDKs, the software development kits, you sort of have to be familiar with some of those languages. And as a result, a lot of times the engineers sort of write that up, and you end up writing the equivalent of a README and basic usage, not really in-depth information unless you can. All right, we talked briefly about tools, and I decided to query about 100 developers who work with docs what sort of tools they prefer, and I asked them their agreement to this question. When I engage in documentation efforts, I prefer to treat documentation like software, using Git, text editors, Markdown, static site generators, building from the server, etc. And about 45% agree, 35% strongly agree. This has really become the predominant way that they prefer to work. And so this sort of presents a new paradigm a lot of times for technical writers. If we've been working in traditional tech pub tool chains that have really robust functionality, the localization, the PDF, the content reuse, all snippets and so forth, now you have to figure out, do I switch over to Docs as code? And if so, what? And how are these engineers going to collaborate, if at all? Do I put all this on GitHub or what? So it really presents kind of a strong challenge. But the Docs as code model can be implemented, of course, with other things like there was a session on MDITA with lightweight DITA and so forth, and you can manage an Oxygen project in GitHub. You can do that kind of thing. But the basic idea that you're managing your docs just like the developers are managing their code is a model that has become the most common way that all developer shops sort of handle their documentation. A while ago, Microsoft, they used to have all their docs in XML. A few years ago, they switched over to a Docs as code model. If you look at other companies, Facebook and Google and Amazon, others, like this is pretty common, you'll find. But mostly just common within the developer areas, because a lot of times developers are more involved in authoring, if not the authors of the documentation. And they're going to use tools that they like, that they know, right? It's natural. Sort of talked about that. If you look at the landscape of tools, it's a jungle. I mentioned Stoplight and README, but there are many other sort of categories of tools. One called Netlify that's very popular, that you can build from the server. You do the same thing on GitHub through something called GitHub Pages. There's even a category of headless CMSs that tries to kind of merge this gap between just working in the raw code versus having some visuals to navigate. And in general, there's a whole culture of forking and building that's kind of might be new. When I was first starting out, I had this doc theme that I built called Documentation Theme Jekyll. Oops. And it just sort of looks like this. It uses Bootstrap as a framework, but it's built on Jekyll. And I just needed it for documentation because I wanted to use Jekyll. Well, I've been watching this over the last few years, and it has been starred 720 times, so people want to follow and watch it, forked 613 times. And people all the time, people come up to me and say, Tom, I use your Jekyll theme as a starting point, and then we built up our own custom thing, but it was helpful getting started. And I'm like, yeah, this is kind of interesting, because I could do the same thing with the SendGrid docs. I could go to their GitHub repo. I'd check whether that's open source or not, but I'm guessing it is if it's on GitHub. I could fork it. I could start customizing it. It's this culture of collaboration and sharing, and people just sort of assume that tools are open source. You want developers to write. You've got, I don't know, plus or minus 50 developers at any time. You can't license them all in some proprietary software. So this open source model, it resonates. It's what the developers are accustomed to, and it tends to work. And it is a fascinating idea to think that, that software could be shared. Imagine if you go and decide to fork RoboHelp and build on top of that and build your own solution. That would be pretty awesome, but no, that's not really something that would ever be done, right, in the traditional publishing world. Which sort of brings me to this really controversial slide that I probably added. I was going to do a real-time demonstration before I get to my controversial slide. But a real-time demonstration, usually you use a tool like Atom or other text editors to work. You don't really have a GUI, right? You've just got a navigation on the left. Typically you have some front matter defined in a syntax called YAML. But if you come in here and just, if I were to say hello everyone, you open up in order to save and publish, you would probably open up the terminal right within your doc authoring system. And using Git, you would add your change, and then you'd commit your change, sample commit, and then you push your change. And on your server is listening for changes to a specific branch, in this case master, and it says, oh, I detect that something has changed. Now I'm going to go kick off a build script, and it's going to build the site, and in however long that takes, in this case it'll take like a minute, it will show the output there. You can also build locally, right? So if I'm working locally, there's a command in Jekyll, bundle exec Jekyll serve, and it will render out my whole website at a preview URL. All static site generators work more or less the same way here. You type Hugo in a Hugo site and you get a local server. Sphinx is a very popular one. Read the docs. You can tell this took 12 seconds, so it's kind of slow, right? But usually as you work, you open up another browser where you kind of have your rendered output, and every time I make a change, it's going to rebuild it. If I were to edit this, it kicks off a rebuild. And if I now go to the actual site, see if it's actually built it yet. Might be too quick. Yep, it's actually built it on the live site. So it's a really, really nifty way to work. I mean, I switched over to this a few years ago, and I can't imagine going back. Whether you use Hugo, Jekyll, Gatsby, it doesn't really matter. You're working in this whole model with continuous integration on the server. That's super compelling. Any questions on that? Any? Okay, so to my controversial slide, why few API writers attend STC? I've sort of had this thought as I've kind of wandered around, and it encapsulates what's different about the API doc space. One, the tools are different, right? Most of the vendors in the expo are mostly irrelevant. A lot of them don't even work on the Mac, right? But even those that do, they're not really the same docs as code space that is so common with what mostly what is used for publishing these sites. The developer audience is vastly different. And people have, it's a different culture and way of working. People want to try things out. They want interactivity. It's not just like a matter of reading or putting into a test system, but directly in the docs, the ability to interact. Documenting code is not a task-based paradigm. If you have a big code sample and you're trying to explain it, you don't start out by saying, step 1, define a variable in line 4. Step 2, insert the parameter. It doesn't really work like that. Things are non-linear. The top part might not be relevant until later. And so if you approach it, from a linear point of view, it doesn't work. The structure refers to the Open API specification, not necessarily DITA. If you want to throw around the term structured authoring, people will not understand exactly what structure you're talking about. And the tools aren't built to process OAS, right? The technical ramp up is steep. It tends to be a defining characteristic about whether you're qualified for certain positions or not. The culture is more of an unconference style. There's also open source tools that are sort of the norm. So all of this is kind of why there's this emerging split between kind of the STC and Write the Docs, because in other sort of groups you have more of this culture and it's more inherent. The Write the Docs was created by somebody who actually built a tool for all of this stuff. The Read the Docs tool is built on Sphinx, and it builds from the server by a developer and so forth. Anyway, food for thought. I probably regret having added that, but sort of explains a little bit of, it kind of suggests that we all live in our own bubbles. The Write the Docs people are in their bubble. The SDC people can be in their bubble. We need more crossover. I came to this conference because the SDC does have a lot of emphasis on the customer, and I feel like that often gets left out from the other discussions. Anyway, I have a final slide here. What are we at, 10:55? Basically, getting an API doc job, you need to have some technical familiarity and some writing samples that demonstrate it. Not too different. And a quick tip and shout out to Season of the Docs. If you're looking to break into API docs, and you're like, I need to build a portfolio that shows that I can write API docs, well, there's this whole opportunity now where you can, get involved into a project, an open source project, and contribute in a more formal model. So check this out, or ask Sarah Maddox for more information. She's sitting up here in the front. Let's see. I think I'm just going to jump down here to the end. One last slide. So the level of involvement you can play in API docs really depends on a few things, right? If you've got super strong technical knowledge, you can do both authoring, publishing, and editing. If you've got weak technical knowledge, you might just be doing editing and publishing. And so there's a place for you along this spectrum, right? If you've got strong publishing expertise, it can sort of allow you to fill a gap in other areas. But definitely, if you want to be a power player, you combine your tech knowledge with your other knowledge of writing, and you can really do a lot. So, all right, thank you. That's all I had. Any questions that you want to vocalize here, or maybe I'll let you just kind of disperse and you can ask me afterwards. But thanks for coming. You can find more information on I'dRatherBeWriting.com. And don't forget, rate this session in the app. It's fun to see. Thanks.